Okay, so now let's talk about different types of elasticities. As I've said already, we're going to look at 4 different types of elasticities. We're going to start our analysis with the one that we have actually already talked about, and that is the price elasticity of demand. And this is also known as the PED for short. And we have already looked at it. So this example that we went through, these are all examples of PED. So let me just write down the definition and notice that when we're talking about definitions in economics, there's no one correct way of doing it. So if you look at different books, you'll find different definitions of even what economics is, let alone other smaller concepts. So the way I like to define PED is that it measures, PED measures the change in quantity demanded when price changes by 1%. So let me just put the percentage change in QD when price changed by 1%. So for example, suppose we're talking about medicines, and what we would expect is that if price changed by 1%, the quantity demanded should change by less than 1%. And that is precisely what we saw here, is that a relatively large change in price would lead to a relatively small change in quantity demanded. Similarly, for something frivolous like a packet of chips, if price changed by 1%, we would expect the quantity demanded to change by more than 1%. So the formula for PED is this. Okay. So the new quantity demanded minus the old quantity demanded divided by new QD plus old QD divided by 2. This is together, this whole thing. And we're going to divide this whole thing by, let me use another ink, new price minus old price divided by new price plus old price divided by 2. This whole thing. Actually, I think some of you may struggle to read that ink, so let me change that. Okay, I'll change it into blue, suppose. Okay, so hopefully this is easier to read, and okay, I'll move this down here. So this is the formula for PED, and let us solve a problem. Let me set up a problem. So suppose, think of any good that you regularly buy. Doesn't have to be anything particular. So suppose when price is, let's say 75, you buy 200 units of this good. But then what happens is that price goes up to, let's say 90. When price goes up to 90, the law of demand tells us that since price has gone down, QD must go down. And so suppose you buy 175 units. So since price have gone up by 15, QD has gone up by 75. And we want to calculate the PED of this. So that's quite simple. If we use the formula, I'll use the same ink. So for the top part, new QD minus old QD. So new QD minus old QD. This whole thing is divided by 175 plus 200 divided by 2. This entire thing is in turn divided by, I'll use blue ink again. So new price minus old price. This whole thing is divided by this plus this divided by, okay. And that's how you set up the problem. Now, if we do the calculations, let's see what we get. On top, we have minus, I'll use green again. Up here, we have minus 25 divided by, how much will this give us? 187.5. This thing is divided by 90 minus 75. So we have 25 divided by, how much does this give us? 87.5. So if we just simplify this a bit, we have minus 25 by 187. I mean, if you guys have a calculator, you can just plug this thing in and see what you get. So what we have is 87.5 divided by 187. And if you plug this into a calculator, what you get is minus 0.4667. Okay. Or I mean, you can simplify and just call it minus 0.47. Okay. So the calculation of PED, pretty straightforward. This is just regular arithmetic. What is important is for you guys to understand what this means, okay? So what this means, this figure, that 0.47 is that, let me write this down actually for you guys. If price change by 1%, quantity demanded will change by 0.47%. So if price change by 10%, quantity demanded will change by 4.7%. So you see, this is not a very responsive relationship. Okay. And now what does this mean? The negative sign in front. We have a negative sign because of the law of demand. If price is going up, QD is going down. If price is going down, QD is going up. That's why PED is always negative. In whatever direction price is moving, QD is moving in the opposite direction. So if you look at the formula right here, if the numerator is going up, the denominator is going down. Or if the numerator is going down, denominator is going up. And so at the end of the day, the value of PED will always be negative. So this is one example of how to calculate and interpret PED. So now let me talk about different values of PED. So first of all, as you guys know, PED is always negative. But within different range, there are different ways of interpreting PED. So let's start with that. Values of PED. Okay. So PED can be less than -1. PED can be between 0 and -1. And PED can be exactly -1. Let me just do it like this. Okay, so let me explain what each of this means. So first of all, you guys should understand why PED is always negative. and that is what I already explained, is that either the numerator or the denominator is always negative and the other is always positive. But once it's negative, what can its value be? If PED is between 0 and 1, what we say is that PED is inelastic. This is important. Inelastic. What that means is, so for example, right here, we calculated PED as minus 0.47. So that's between 0 and minus 1. And what that means is that a 1% change in price is going to lead to a less than 1% change in quantity demanded. So price is not very responsive, sorry, quantity demanded is not very responsive to a change in price. Okay. If PED is less than minus 1, so for example, PED is minus 1.5. So what does that mean? That means that if price change by 1%, QD will change by 1.5%. If price change by 10%, PED will change by 15%. So that means that PED is elastic. This is also important. What this effectively means is that the quantity demanded of this good is very responsive to a change in price. However, by whatever percent the price change, the change in QD will be much larger. Okay. And finally, we come to this where PED is minus 1. Okay. What that means is that basically a 1% change in price leads to a 1% change in quantity demanded. So we say that PED is unit elastic. Okay. But now there are two more extreme cases. You won't see this often in real life perhaps, but they do exist, which is if PED is equal to 0 and if PED is equal to infinity. Okay. To explain this, I'm actually going to draw two diagrams. It's easy to understand this diagram. In fact, I'm going to draw diagrams for all of this. So one for this, one for this. Okay. So if PED is elastic, what we have is a case such as this. And if PED is inelastic, we have a case such as this. Well, that doesn't look too nice. Something like this. So we have Q here, P here, Q here, P here. And what we see is that a small change in price leads to a large change in QD. But for PD inelastic, what we see, okay, that's not right. Let me just redraw this. It doesn't look very nice. Okay, that's better. Over here, what we see is that a relatively large change in price will lead to a much smaller change in quantity demanded. Okay. So unit elastic, it's not very interesting. I'm just skating over that. Let's come to the case where PED is 0. So before I draw the diagram, let's talk about this. What does PED equal to 0 mean? To define this, it means that a change in price has no effect on quantity demanded. So effectively, if we go back up to the formula right here, what we have is for PD to be 0 is we have 0 and we have some number down here. So price is changing by a certain level, but that has no effect on quantity demanded. In that case, what will the diagram look like? Price can change, but quantity demanded will not change. The diagram looks like this. It's a straight line. Okay, so regardless of what the price may be, quantity is fixed. And so this is known as PD is perfectly running out of space to write. Okay, so what we can say is that PD is perfectly inelastic. Okay, and this is also important, obviously. So when might we see this? What type of goods experience a perfectly inelastic demand curve? Remember, these are demand curves. This is demand, this is demand. So what type of good will experience no change in quantity demanded, regardless of what's happening to the price level? And the answer is necessary goods. So medicine, for example, if you have diabetes, for example, and you need insulin, doesn't matter by how much the price goes up, you will have to continue buying the diabetes. So your quantity demanded will stay fixed. Mm, Another interesting example is uh, students' ID cards. Now, I think in BRAC you guys don't have to pay for your ID cards. They're given to you for free. But if suppose there was a price involved with it, then suppose you have to pay 1,000 taka to get your ID card, and then you enroll in BRAC, and you've done a few semesters, and then the authority tells you that you have to start paying, instead of 1,000, you have to pay 2,000 for your ID card. So what are you going to do? Are you going to stop attending BRAC because you don't want to pay the 2,000 taka? Not really. Even though prices have doubled, you will continue to use your ID card. Even if price went up to 5,000, even if price went up to 10,000. You're not going to leave your university because you don't want to pay 10,000 taka for an ID card. So that's another example of goods where change in price has no effect on the quantity demanded, and these are called perfectly inelastic uh, demand curves. Change in price has absolutely no effect on quantity demanded. Let's take this down. And I think we can take this up then. Put it here. We can get rid of this. This comes up here. And when PED is infinity, that means that this means that PD is perfectly elastic. Okay. What that means is, let me define it. Mm, or let me draw the diagram first. I think that will be more helpful. So we have Q here, we have P here. This is our demand curve, this is the price level, and Q naught, Q1, Q2. So the intuition behind this, if price were to rise even by a little bit, demand will become zero. See, now this is price P naught, and if price goes up even slightly, there is no demand. There is no demand. So the way of defining this is that even if price increase slightly, not demand, sorry, quantity demanded will fall to zero. Okay. And so this is perfectly elastic. Demand, quantity demanded, is very responsive to a change in price. Whereas in number 4, what we saw was that quantity demanded, or the demand curve, was not responsive to price at all. It was perfectly inelastic. Over here, perfectly elastic. So what type of good might this be? What type of good will have a perfectly elastic demand curve? Well, uh, think of two people selling vegetables out on a street side by side. Okay, so they're selling some basics like carrots and cauliflowers and stuff like that. They have two carts, they're side by side. Now here's the thing, suppose they're selling carrots for, I don't know how much carrots cost. Let's say, for example, they're selling for 30 taka per kg. They're both selling the same good at the same price. If one of them tries to sell carrots even at a slightly higher price level, if he tries to charge 31 taka per kg, what happens? No one is going to buy carrots from him. You just go to the other guy and buy the carrots from him. So he can't afford to increase his price even a little. If he does that, his demand will fall to zero. So that is an example of a perfectly elastic demand. So this is where we are going to leave this, but later on in the course, you are going to do a chapter called Perfect Competition, where you will talk a lot more about situations such as this, where demand is perfectly elastic.